So hi everyone, this is Jay, your instructor for Computer Networks, and in this session we are going to see the sliding window protocol. So what is sliding window protocol? In sliding window protocol, sender sends more than one frame to receiver, and the sender window size is n. It means that sender can send 3 frames at a time, it can send 5 frames at a time, it can send 9 frames at a time, whatever the capacity of the sender is. But the receiver window size can be either 1 or n. So receiver can receive either 1 frame at a time or it can receive n frame at a time. The sliding window protocol is full duplex. It means that sender can send multiple packets and it can receive as well. If you remember, in the go back end, the sender sends packet and it waits for the acknowledgement. And this process is very time consuming because after sending every packet, sender is expecting acknowledgement and it will add so much delay. So that problem is overcome in the sliding window. So in the sliding window, we will send more than one packet at a time and we will also receive that many packets. So stop and wait protocol is a half duplex, but the sliding window is full duplex. Sliding window protocol is divided into two types, the go back N and selective repeat. We are going to discuss the go back N protocol. So let's see. There are two devices A and B are there. In the go back N protocol, the N is the size of the sender's window and receiver's window will always be 1. So this is the example of go back 3. It means that sender's window size is 3 and the receiver's window size is 1. So from the receiver's window, what information we get? The current position of the receiver's window will tell you that what packet receiver is expecting. So right now receiver is expecting packet 0. So A will send the packet 0. When B receives the packet 0, the receiver's window will slide from 0 to 1. So it means that B has received the packet 0 successfully. For the next time it is expecting packet 1. After some time A will send the packet 1. When B receives the packet 1 which it was expecting, the window will slide from 1 to 2. So for the next time it is expecting packet 2. And after some time A will send the packet 2 and window will slide to 3. The current position of the sender's window tells you that how many packets are in transmission, and the current position of the receiver's window tells you that what packet receiver is expecting next. So the how many packets are in transmission? 0, 1 and 2 are in transmission and the receiver, which is B, is expecting packet 3 next. So as B received the packet 0, it will send the acknowledgement 1. Always remember the acknowledgement number is +1 than the sequence number of the packet. So for the receiving packet 0, B has sent the acknowledgement 1. Now when A receives the acknowledgement 1, A thinks that okay, the packet 0 is received by the device B successfully, so the window at the sender side will slide and A will send the next packet in the sequence, which is packet 3. Now B has received the packet which it was expecting, so window at the receiver side will also slide. It will be positioned at 4. Now the current position of the sender's window tells you that how many packets are in transmission right now, and those packets are not acknowledged. So what is the current position of the sender's window? The current position of sender's window is 1, 2, 3. It means that packet 1, 2 and 3 are in transmission currently and sender has not received acknowledgement for those packets. And what is the current position of receiver's window? It is 4, so it is expecting 4th packet next. So B will send the acknowledgement 2 for the packet 1. As the A receives the acknowledgement 2, A knows that its packet 1 is received by B successfully, so window at the sender side, window at device A side will slide and A will send the next packet, which is packet 4. As B receives the packet 4, the window will slide to 5 because it got the packet that it was expecting. And A will receive the acknowledgement 3 for the packet 2. So when it receives the acknowledgement 3, it knows that packet 2 is delivered successfully. So A will send the next packet, which is packet 5, and window at the receiver side will slide to 6. Now let's see the current position of A's window, which is 3, 4 and 5. So 3, 4 and 5 packets are in transmission currently. We have not received any acknowledgement and we are expecting packet 6 at the receiver side. So we will receive the acknowledgement for the packet 3, which is SEK4. So window at the sender's side will slide. So sender will send the next packet, which is packet 6. B receives the packet 6, so window will slide to 7. Then A will receive acknowledgement 5. As it receives the acknowledgement 5, window will slide and A will send the next packet, which is packet 7. And as B receives the packet 7, the window will slide. So right now B is not expecting any more packets. But A has not received all the acknowledgement. Right now 3 packets are in transmission currently, which are 5, 6 and 7. We have not received acknowledgement for 5, 6 and 7 packets. So A will wait for acknowledgement. As it receives the acknowledgement for packet 5, which is ACK6, so window will slide and there is no new packet which needs to be transmitted, so A will not send any other packet. Again it will receive the next acknowledgement, so window will slide and now it has no packet to send. So this is how the go back N works. We have not considered any packet lost or acknowledgement lost. But now let's see what happens if acknowledgement lost or packet is lost. So let's see first what happens if the acknowledgement is lost. Again this is go back 3. We know that the N represents the size of the sender's window. So sender window is 3. And in the go back N, receiver's window will always be 1. Now we know that B is expecting packet 0. A will send the packet 0. As it receives the packet 0, the window will slide to 1 at the receiver side. Then after A will send the packet 1, then B will receive the packet 1 and window will slide to 2. And A will send the packet 2 and B will receive the packet 2 and it will slide to 3. The current position of the receiver's window is at 3. It means that it is expecting third packet for the next time. And current position of the sender's window is, so 0, 1 and 2 are in transmission right now. So for the packet 0, B will send the acknowledgement 1 and as the A receives the acknowledgement 1, A knows that its packet 0 is received by device B successfully, so window will slide at device A side and A will send the next packet, which is packet 3. But unfortunately the packet 3 is lost in the network. Now packet 3 is lost in the network, so device B is expecting packet 3 and it has not received yet. But A will receive the acknowledgement for the packet 1 first. So for the packet 1, B will send the acknowledgement 2 and as the A receives the acknowledgement 2, the window at the sender side will slide and A will send the next packet, which is packet 4. Now you can see that B is expecting what packet? The packet 3, right? But it is receiving which packet? The packet 4. I always tell that in the go back N protocol, the receiver is very stubborn. So receiver is supposed to receive the packet what it is expecting. If it is not receiving the packet that it's expecting, so it will discard that packet simply. So as it receives the packet 4 and it is expecting packet 3, it will discard the packet 4. And A will receive the acknowledgement 3 and window will slide and A will send the next packet. Again B is expecting packet 3 but it is receiving packet 5, so it will simply discard that packet and it will continuously wait for packet 3. So receiver B has not sent any acknowledgement for the packet 3. A will wait for the acknowledgement 4 and it will continuously wait and it will wait until the timeout time. So after the timeout time, A will not receive any acknowledgement for the packet 3. So what A will do in this case? When A doesn't receive any acknowledgement in the go back N protocol, A will go back N step from the lastly transmitted packet and it will send whole window again. So in this example, which packet was transmitted last? The packet 5. And what is the window size? Which is 3, because it is go back 3. So in this case, A will go back 3 steps from the lastly transmitted packet and it will send the whole window again. So lastly transmitted packet is 5, so it will go back 3. So it will go 5, 4 and 3. So from the 3 it will send all the packets again. So it will send the packet 3 again. So as B receives the packet 3, the window will slide to packet 4. So it is expecting packet 4 next time and it will send ACK 4. Then B will receive the packet 4. As it receives the packet 4, it will send the ACK 5. And it will receive the packet 5 and it will send the ACK 6. So always remember, in the go back N protocol, it is totally dependent on the window size. And if receiver is not receiving any acknowledgement in a particular amount of time, in that case it will go back N step and it will send the whole window again. So this is it for today's session. If in the next lecture we will see what happens when the acknowledgement is lost. Thank you so much.